Imagine standing at the edge of the known universe, peering into the unknown with a telescope that is peering billions of years back in time, at the very fabric of existence itself. The vastness of the cosmos has always stirred the human imagination, from the first time ancient civilizations gazed up at the stars, to the revolutionary discoveries of modern scientists. But today, thanks to advanced technologies like the James Webb Space Telescope, JWST, we are beginning to witness phenomena so remarkable that they not only challenge our current understanding of the universe but also confirm profound predictions made by one of the greatest minds in scientific history, Albert Einstein. For over a century, scientists have grappled with one of the most profound questions in physics and cosmology: what is the true nature of the universe? Did it have a beginning? And if it did, can we, with our limited knowledge and technology, ever truly observe that moment, the Big Bang, when space and time as we know them began? In a groundbreaking prediction, Einstein suggested that, no matter how powerful our telescopes or how advanced our technology became, we would never be able to directly observe the beginning of the universe. This assertion, though seemingly bold at the time, now appears to be more than just an educated guess, as the latest discoveries from the JWST appear to confirm his hypothesis in unexpected ways. But what exactly is it that the JWST has found? And what does this mean for our understanding of the universe and its origins? Einstein's prediction that we would never be able to see the absolute beginning of the universe was born out of a deep understanding of both physics and the limits of observational science. Back in the early 20th century, scientists were still coming to terms with the true scale of the universe. The idea that the cosmos was vast, filled with billions of galaxies, was a revelation that had only begun to take shape. Edwin Hubble's discovery in the 1920s, that galaxies were moving away from each other, laid the foundation for the theory of an expanding universe. This observation led to the realization that, if the universe was expanding, it must have once been concentrated in a single point, a singularity. From this singularity, everything we know, the stars, the galaxies, the very fabric of space-time, emerged. The Big Bang theory, proposed by Belgian physicist Georges Lemaitre, built on this idea, suggesting that the universe began as an infinitely small point, which exploded and expanded to create the vast universe we see today. But despite accepting the Big Bang theory, Einstein harbored doubts about one key aspect: the idea that the universe had a definite beginning. He was concerned with whether the concept of an absolute beginning, something that could be observed or detected, was even possible. And if such a beginning existed, could we ever truly witness it, given the limitations of our observational tools? The answer, Einstein concluded, was no. The universe, he speculated, was expanding in such a way that the very earliest moments of its existence would be moving away from us at an ever-increasing rate. As space itself stretched and expanded, the light from those early moments would become increasingly redshifted and faded, eventually disappearing beyond our ability to detect it. Another part of Einstein's reasoning lay in his theory of relativity, which suggests that space itself is not a static backdrop to events but is instead a dynamic and malleable entity. If space is curved, as Einstein proposed, it could be that the edge of the universe was not a simple boundary but a cosmic horizon, an invisible barrier that we could never cross or see past. The universe's expansion would cause this horizon to stretch further and further away from us, effectively sealing off the past from our view. The very notion of a beginning could be rendered unknowable. In Einstein's view, no matter how advanced our telescopes became, we would always be limited by the expanding nature of the universe and its inherent curvature. Fast forward to the present day, and we find ourselves in an era of unprecedented discovery. The James Webb Space Telescope, launched in December 2021, has already begun to revolutionize our understanding of the universe. With its ability to see in the infrared part of the spectrum, the JWST is able to peer through cosmic dust and gas, uncovering galaxies that formed just a few 100 million years after the Big Bang. The telescope's remarkable sensitivity allows it to observe some of the faintest and oldest light in the universe, providing a clearer view of the distant past than ever before. As the JWST began to peer into the early universe, one of the most remarkable discoveries was the detection of galaxies that are older than scientists had previously predicted. These galaxies, some of which formed within the first few 100 million years after the Big Bang, challenge our current understanding of cosmic evolution. The discoveries made by the JWST have forced astronomers to reconsider the timeline of galaxy formation, suggesting that the universe may have been able to form stars and galaxies far earlier than previously thought. This has led to a re-examination of existing models and theories about the rate of expansion and the conditions necessary for galaxy formation. However, among these discoveries, one in particular stands out: a mysterious void discovered in the early universe. This void, initially detected by the JWST, has puzzled scientists, as it appears to be an enormous region of space devoid of galaxies and other forms of matter. At first, the void seemed to confirm a long-standing hypothesis in cosmology, the idea of the dark ages that followed the Big Bang. This period, which occurred before the first stars and galaxies had formed, was thought to be a time when the universe was dark and featureless, devoid of any light-emitting objects. However, the discovery of this void has complicated matters, as it appears to be located in an era far too early for such a large absence of matter to exist. Scientists have long known about the existence of voids in the universe, vast expanses of space where galaxies are rare or entirely absent. These voids are not a mystery in themselves, but their locations and sizes have always been subject to some debate. Voids are typically found on the outskirts of galaxy clusters, where the gravitational influence of nearby galaxies has cleared out large areas of space. However, the void discovered by the JWST is different. This void is located in the distant past, at a time when the first galaxies were thought to be forming. Its size and apparent emptiness challenge current models of how the universe should have evolved. At first, some scientists speculated that the void might simply be evidence of the universe's infancy, a cosmic blank slate before the formation of stars and galaxies. However, as the data continued to come in, it became clear that this void was far too large and complex to fit within the existing models of the early universe. Instead of simply being a region of darkness, this void appears to be a vast, empty space that defies the smooth, homogeneous distribution of matter that is typically expected in cosmological models based on the Big Bang theory. Some have even suggested that this void could be a remnant of a primordial structure that formed in the very early universe, perhaps even before the formation of the first galaxies. What makes this discovery even more intriguing is the possibility that this void could be the key to understanding the true nature of the universe's origins. Could it be that the universe itself emerged from this very void? After all, a void is, in a sense, a space with no matter, no energy, nothing. And yet, from such nothingness, the entire cosmos could have been born. The very idea challenges everything we thought we knew about the creation of the universe. But what if this void is not just an empty space, but a remnant of the conditions that existed before the Big Bang? If this were the case, it would suggest that the origins of the universe are far more mysterious and complex than we had ever imagined. But what exactly are these voids? What do they mean for our understanding of the universe? And could they be the remnants of something much more profound, a singularity, or perhaps even a window into parallel universes? In cosmology, a singularity refers to a point in space where the gravitational forces are so intense that all our current laws of physics break down. A singularity is thought to exist at the heart of a black hole, where matter is compressed to an infinitely small point, creating a region of space with infinite density and gravity. The conditions within a singularity are so extreme that they defy our understanding of physics. Could the void discovered by the JWST be the remnant of a singularity, or could it be the birthplace of a new universe entirely? These questions have led to some wild and speculative theories about the true nature of the universe. Some scientists have suggested that the voids could be the result of a collision between different universes in a multiverse scenario, where our universe is just one of many, each with its own distinct properties. Others have speculated that these voids could contain hidden forms of matter or energy that we cannot yet detect, perhaps even dark matter or dark energy, mysterious substances that are believed to make up much of the universe but are still largely unknown. Whatever the true nature of these voids, the discovery has confirmed that our understanding of the universe is far from complete. It suggests that we are still in the early stages of unraveling the mysteries of the cosmos, and that the answers to the most profound questions of existence may lie far beyond the reach of our current knowledge and technology. As we continue to explore the universe with instruments like the JWST, we may uncover even more startling discoveries that challenge everything we thought we knew about the origins and evolution of the universe. In the end, Einstein's prediction that we would never be able to observe the absolute beginning of the universe may have been more accurate than anyone could have imagined. The discovery of a strange void in the early universe, along with the many other groundbreaking observations made by the JWST, reinforces the idea that the origins of the cosmos are far more complex and elusive than we ever anticipated. Perhaps, as Einstein suggested, the true beginning of the universe is something that will always remain just beyond our grasp, a mystery that will forever challenge our understanding of space, time, and reality itself. As we continue to peer deeper into the cosmos, there is no telling what new revelations await. Whether these discoveries lead us to a greater understanding of the universe's origins or raise even more questions, one thing is certain: the quest for knowledge about the cosmos is far from over. With each new discovery, we move closer to unraveling the greatest mystery of all, our place in the vast, mysterious universe.